Hello and welcome back to Wildcard Workshop. We are once again continuing on with our VSS tutorial. In this particular video, we're going to cover the process of taking a creature, converting it into data that we can put on items. We will cover the process of taking them out of the item and turning them back into creatures later, but from what I show you today, I'm sure you'll be able to figure out the majority of how that works at least. Now, we are going to be looking at just sort of the rough process. Again, remember what I told you before, we don't want to polish it right now because it's really easy to, start working on a feature or part of the mod and just start polishing and polishing and polishing and polishing. And then the next thing you know, you spent 2 weeks just trying to find the right settings on this one little part, and the rest of your mod, you haven't even gotten to the point of making sure it all works yet. So get through the entire mod, get it working, polish afterwards. So let's go ahead and hop over there. I'll show you how it's done. So here we are in the dev kit. Got our VSS project open. I've already opened the Primal Game Data. Just set it down here. So I have made a few changes to some files. First of which, up in here in our Virtual Crystals parent class, and in the Sentry class, if we go to change modify properties in the parent, I've set the equip requires explicit owner classes to the Primal Structure Virtual Station Platform VSS. This will make sense in a moment. Also along with that is the item type is set to equipment and the equipment type is set to trophy. Again, these are all sort of tied together. I'll explain that in a moment. And in the Sentry Crystal class, changed it so that it could probably have done these on the parent as well. Disabled can be blueprint. Enabled prevent upload. We don't want these going up cross server. Allow use in inventory. These aren't going to be usable. Prevent item blueprints. I can't remember. I just checked both of these to put them in line. I can't remember which one is the one that takes precedence. So I just did both. Now, if we open up our virtual station platform, go there, and the inventory component. So in the inventory component, changed it to equipment must require explicit owner class. Now remember, that was that one that we set on the Virtual Crystal parent, saying that, hey, we want to require this one. This is sort of the opposite side, where it's saying only allow things that require this particular class, this particular blueprint type, to be equipped. And I've also set an equipable item types trophy. So this platform will have an equipment slot for a trophy, sort of like you see with the artifact pedestals. Disabled crafting, disabled repairing. That one might want to be disabled. I need to double check that one. I have increased the inventory items and slots to 1,000. Again, this will make sense in a moment. And then remove the craft queue entries. This probably wasn't necessary because crafting is disabled. But in experimenting with settings, some things were just kind of toggled on and off just to see how they worked. So, in our Virtual Station blueprint, some things that I changed were I went here, I found blueprint multi-use entries, and I enabled that. We're going to need it. And that was it, actually. That was the only thing that I changed in the actual structure blueprint. Now, everything that we did as far as... I'm going to open this up because we'll explain this in a moment too. Everything that we did as far as functionality in this tutorial is in here. So I have added a few classes and made some modifications to one. So if you remember from our multi-use tutorial, we've got BP get multi-use entries. I have created a new entry here for the virtualization process. I've set my use index to 20,000 up and out of the way, gave it a special color, so on and so forth. These might get tweaked later on. I add it to the multi-use array and then return that. And then on BP try multi-use, I tell it, hey, do your thing. Switch on int from the selection of the use index on 20,000. And if the use index is 20,000, we do the do virtualization process. And that's what all of these functions are. Now, I prefer to do things in more of a methodical manner, like a conveyor belt. So I'll break down parts whenever I can into specific tasks. So the first thing that we do is we get the player controller for this, mostly so that we can do messaging to the player that's actually trying to do the virtualization process, and then I cast it to shooter player controller. That'll make sense in a moment. So our tasks for this process right now are, first we need to find a creature. If we have found one, then we need to strip it of all items and saddles. And those will go into the inventory of the platform itself so that nobody accidentally loses items, although it still could happen if the platform is full. But we've given a pretty big buffer of 1,000 items for things to be stored in there. Then we need to convert the target creature. This will return our out VSS data, and what this is the custom item data structure. This will then be, we have to create the Sentry crystal, and then we store our item data on it. And then we need to destroy the creature that we are virtualizing. And then we can send a message saying, hey, we're done. So let's take a look at each of these in turn. First things first, we need to find a creature. So our inputs on this one is just for player controller. And then our outputs are if it's a valid target and target creature. Now you could say, well, if this isn't, why do you need this? It's just a little bit faster than doing like it is valid. But we definitely don't want to cut off execution in the function, because if we do, and then the function ends early and it still actually continues on to the rest of these. So we want to cut off execution if it's not right. So we could do this one, or we could have just done like it is valid on here. I prefer doing this one just because it's an easier state track. So when we come in, we've got our for player controller pops down there. It all just goes to messaging. So our first thing that we do is we run a server awk tree. And what this is our search process. So we give it a reference to the world. We tell it the location. So I give it the transform of the actual platform structure. What this is based on the origin of the mesh, basically. So this will give it in the case of the platform, the origin is in the center at the bottom. So this will give it the center bottom of the structure, which works for me. And then we need to give it a radius. So this is like a sphere radius. I believe I set it to... I need to disable that because these are, yes, right there. Awk tree search radius 800. So I did a lot of these variables, and we'll be doing many more. For the most part, this is a better way of doing things, because what happens is if you create a variable and you plug that in for your functions and things like that, you can come out here to the defaults and you can change the values without having to recompile the blueprint. You just have to save the changes. Whereas if you change like a value, if I were to change this to like a 2, I'd have to recompile a blueprint. So anyways, we've got our server awk tree here. Now what this will do is it'll just like take an instantaneous snapshot of the radius that we are specifying here. And if anything matches this awk tree type, we've got a whole list here. We've got stasis components, player pawns, dino pawns, pawn structures, targetable actors, so on and so forth. For whichever one you select, any actors in that radius, it will return an array of them. But here's the thing. We only want one creature. We want this to be an explicit action, not something that's done by accident. So we're not going to do a bunch of, whatever's in there, we're just going to virtualize. It's going to be a one creature kind of thing. You have to explicitly take your singular creature up there and then start the virtualization. Reason being not only because it's easier to track in code, but also because I want to try and make a system of augmenting these sentry crystals using artifacts, and doing that in groups would be a problem. It would open itself up not only to abuse, but also some very confusing code for tracking it, probably. Anywho, so we have a few local variables here. We've got actors on platform. This is what it returns from the Octree. We've got a return value. This is just to track that state. What it is this return value is just what I return on the valid target found. So basically, whenever the state changes to a certain expected format, I save that, and then whatever it is at the end of the execution path is what I return. And then we've got the out target, which is our target creature that we're going to virtualize if one is found. So first thing, after we've got our array, we do a check on the length of it. If it is more than one creature, okay, true here. We're also going to save the inverse to that value. Basically, if it is more than one creature, we're going to set the return value to false, meaning we did not find a valid creature. Then if it is more than one creature, we will send out a message, error message too many. I've got a notification sound for failure and for success. We've got different messages depending on the reasoning. And this is just using the client server notification single. This does have to be called from server. This is not happening. None of this is happening client side. So if it is less than or equal to 1, basically, the inverse of greater than 1, it'll come down here. We'll do the inverse again, checking to see if it's less than one creature. If it is less than one creature, we send out another message saying, hey, there's no targets that we can use here. If we have exactly one creature on the platform that returned from the Octree, we make sure that it is valid for one, because weird things can happen sometimes, so this is just a safety net. If it's not valid, send out a message saying, hey, invalid target. Then we'll do a cast, just to make sure that in case it may be a modded creature that somehow is falling underneath that Dino Pawns Octree type, but isn't actually a child of Primal Dino character. Maybe it's a particularly special mod that has done some massive modifications to the game. But under those circumstances, yes, while it would be cool to be able to support that, chances are if it can't cast to Primal Dino character, it probably won't work properly with this mod. So we're going to exclude anything that does not fall under Primal Dino character. If the cast fails, we'll also return that same invalid target message. If it's good, okay, then we'll do one more thing. We're going to check the targeting team. We don't want you people making these sentry crystals out of enemy creatures and dinos or wild ones. We want this to only be your own tamed creatures. So we're going to check the targeting team of the target creature that we've got against the targeting team of the virtualization platform. If they are the same, then they belong to the same tribe or person, and we will continue on. If they are not the same, then it's either wild or it's an enemy or something like that. We'll send out a message saying it's an unknown creature. Same deal, we give it a notification saying this ain't right. Then if everything goes according to plan and it satisfies all of our conditions up to this point, we will save it into the out target variable here. And then when we return, we'll return it all. After that, we do a check, just a branch on valid target found. If we have one, then we're going to use it. Now, for strip target creature, Now for strip target creature, this is a simple one, okay? We've got our target creature, we bring it in, we get a reference to its inventory component, and we want to get the arrays of equipped items and inventory items. So I've got a sequence here. What this does is it'll go through the execution process for one line and then for another and then for two. Now this does work in sequence. It won't start the next pin until the last one is complete unless there is a deferred action here, like a delay nodes for something if you're using it in the event graph. In those circumstances, once it hits that deferred node, it will move on to the next pin and just split execution there. So keep that in mind. But within a function itself, these will happen in sequence. It'll wait until the last one is done before it starts the next. So the first thing we do, we grab the equipped items. We go in a reverse for each loop. Now you won't find this in the dev kit normally. This is not why this isn't a macro that is packaged with UE4. I do not know. But what this is I have created a small macro library, and we might add to this as the project continues. Let's see if we can get it open. There we go. What this is this is a for each loop that works in reverse. I mean, that's simple enough. That's what it is. It's not packaged with it, but you can find it in that macro library if you want to see how it works. The reason we are doing this, if you are not familiar with how arrays work, or how vectors work, because the dynamic arrays work a bit more like vectors than they do the static arrays that you might be used to in C++. When you modify an array, if you remove an element, there is a problem that occurs. Okay, if you're using a regular for loop or for each loop. Let's say we're on index 3, and then you decide, oh, I'm going to remove index 3. So now you finish that loop, and the for each loop will increment to the next element. The problem is you just removed element 3, which means that what was element 4 is now element 3, and you've inadvertently skipped over it. Because when you remove an element, all of the elements after it move in the array. Their indexes change. So the way that we handle this in a situation where we're going to be potentially modifying or removing elements in an array is we'll use a reverse for each loop. We start at the end and work our way back to the start in this case. From the last element to the first. The reason being, if we have made a change to, say, remove element 5, and then the reverse for each loop decrements, okay, it goes down. Well, element 6 is the one that now takes over element 5. We've already passed that one, so now those changes in the array size are happening behind us instead of ahead of us, okay? So that's why we use a reverse for each loop here, is because what happens is we're going through it, we're checking each item, we are adding each item in the inventory of the creature to the inventory of the platform. What it's doing is it's making an exact duplicate of that item. After that, we have to remove the old one because this is a duplicate. So what we do is we get the item ID of the old one, and then we do a remove item. Okay. So we're making a copy, and then we're deleting the old one. And we do that not only with the equipped items, but also the inventory items. And this will basically strip the creature of all items that it has so that they are safe and sound in another inventory for when we destroy the creature. After we have removed all the items, we're also going to strip it of all buffs. I've just got deactivate buffs for buff class primal buff. And what this should do is just turn off all buffs on the creature, just all of them. Okay, it has no items anymore. It should just destroy all of the buffs. We don't need them. We don't want them for what we're doing with this mod. So get rid of all of them. We're stripping the creature of anything that it has that isn't just straight up part of the creature itself. So now, after we have stripped the creature of all of its items and buffs, we want to convert it. So we take the target creature again. We've got a local variable here, it's just a string, and I'll show you why. So we've got a function here called getDinoData. And what it does is it returns a struct of all of the data, all of the byte data. Basically, this is all of the serialization data for a dino. We get its class, we get all of the byte data, we get its name in the map, and then its creature name. I can't remember which one of these is the difference. And then we're going to loop over this byte data. Now we can't, if we look at the custom item data struct, okay, which is what we need for this, you'll notice there's the name, which we use, the data strings, which we're making use of here, floats, objects, classes, and names. Unfortunately, there isn't an array for byte data, so we have to convert it to one of these other types. The easiest one is just to convert it to a comma delimited string. So we'll iterate over this entire array. We will append each byte with a comma, and then we will save it back out. Okay, we'll add it back to the Dino data buffer. So we take it in what already exists, then we append a byte, and then we add a comma, and then save it back out. So basically, we're just appending all of these bytes into one long string. Then we will make an array with it. We'll include the dino name in map and the dino name as the first two elements in this array of strings, and then we'll do our dino data comma delimited string here in element 2. And then we'll just save the dino class into the actual custom data classes here array just as one element. We'll construct the custom item data struct, and then we'll return it as out VSS data. Simple enough. This is just migration of data for this function. Now, we've got our data. So we need to make a sentry crystal. This one's super easy, but this one might get some more polish going on later on. First thing we do, we go add new item. It needs a reference to the inventory component. We're going to set it to sentry crystal generic. We're going to tell it equip item. So as long as the settings match up, okay, for equipment trophy, the equipment slot type, all of that, when we hit equip item, it should automatically equip it on the inventory component. If they don't, it does not. This is something important to keep in mind if you're going to try and do this equip item stuff. If they don't match up, if it's not an item that can normally be equipped, this will fail and your return value will be none. So something that I should have done, and I will probably change later on, is done an is valid on this just to make sure that we're not trying to do anything afterwards to it. But generally the easiest way to make sure that this is going to work is do it not without the equip item checked first, and then when it deposits the item in the inventory, just see if you can put it in the equipment slot. Okay? If it doesn't, then this equip item is going to fail every time. So make sure that those settings, the ones that I showed before about your explicit owner class, the equipable item types, and all of that matches up properly. So we've also got it as don't stack. We don't want these stacking. That's going to result in a loss of data. Force no blueprint. Just want to make sure it's not going to be a blueprint. Quantity override. Just making sure there's one. And that's it. Now, the item, okay, this returns a primal item reference. So from that, there is a function called set custom item data. This will add, we can use that struct that we made before as the parameter in this function, and it will add that data to the primal item. And it's a way of persisting data on primal items. Normally you can't do that. Normally variables that you add to primal items do not have a save data flag that you can enable on them. Normally, if you want to do that, you would have to co-opt variables that were not in use for a particular item type as a way of saving any kind of custom data to it. Now we have this custom item data array that we can use. It's super handy. I wish I'd had it a few years ago. It would have saved me a lot of headaches. But you can find it here if you want to see what I'm talking about. I've got right here, custom item datas. And each one just has all of that. These arrays can be removed and added. Just make sure you're using the functions and not just trying to modify the arrays themselves. I'm not sure if I imagine that these functions were added for a specific reason. I haven't looked into the underlying code to see if there was a particular one. But generally, if you've got functions for setting and removing and changing data, use those over just adjusting arrays themselves. There's usually a reason. So now that we've dispensed the crystal, it should be in the inventory of the platform now. We want to destroy the target creature. Simple enough. I understand this seems a little ridiculous to make a function just to call one singular function. It's more of a placeholder. There's going to be more going on in here probably later on. Some visual effects, things like that. So once we have the creature has been destroyed, we want to send out a message saying, hey, we're done. It's good. I can show you real quick how this all looks at the end. So we've got our platform here. And we've got our little Anki here. Okay, so what I'm going to do is I'm going to equip the saddle on the Anki. I'm going to transfer all the items over there just to demonstrate this in effect. And then we're going to start virtualization. Bam! See how quick that was? It wasn't very flashy. That's what I mean, but it worked. And just to kind of show, well, it'll be a little bit difficult to show that the data is on there right now, but as you can see, there is now a generic Sentry Crystal in the equipment slot of the virtualization station. We can take it off, we can re-equip it, so on and so forth. So now we've got that item. We're fairly confident that the data is on there, but if it's not, we can find out later and see what's going on. We do have the general process in effect though, and you'll notice got the saddle, it's the same saddle, same amount of armor, everything. All of the items are in here, so they were not lost when I mistakenly left them on my Anki. When I started this process, all is safe. And there we have it. We now have our creature saved onto an item that we can use as a data source for the sentry towers themselves. So we'll probably start looking at that on the next episode, is the actual sentry towers and getting that data from it. We might need to make a little simple mesh first for the sentry crystal so that we can attach it, but that'll be something for me to worry about between now and then. So now we've got our creatures in items. Okay, we've stored that data into the custom data info on those items. Now, the trick is going to be getting them back out and also modifying them. Like, that's something that I want to do, is I want to make the creatures that we spawn from these crystals look unique. So we're going to do some material work as well. I'm going to do some experimentation to see how we can apply this stuff and expect them to be, persistent, or at least as far as making sure that they show properly on all clients. Because it's really easy to change a material on the server side, but materials do not replicate. So it's a little bit, we're going to have to do some work on that one. I'll have to show you some tricks around that. that is for a future tutorial. It probably won't be the next one, but you get to look forward to that. I will show you how to make that material that I'm working on. So far it's starting to look pretty cool. In the meantime, hope you all have a wonderful day. Happy modding.